Hello everyone, we are solving problems on the superposition theorem. In that, next question is find current I in the following circuit by using superposition theorem. This is the given circuit. Okay, whenever we are solving the problems by using superposition theorem, one source must be acting alone and other sources, that is current source is replaced with open circuit and voltage source is replaced by short circuit, because the internal resistance of current source is infinity, that is open circuit. The internal resistance of voltage source is short circuit, that is 0. Now, so this is the circuit. First I am considering this 1 volt source. So replace this 1 ampere source with infinity, that is open circuit, and this 2 volt source with short circuit. Then circuit becomes like this. If you observe this circuit, okay, the response, that is the current due to this 1 volt source, let it be I1. If you notice here, this looks like a bridge circuit. Okay, this is a bridge circuit. Now check whether the bridge is balanced or not. So how to check whether the bridge is balanced or not? Opposite multiplication of opposite impedances are equal. Here the opposite impedances, that is the opposite resistance, are this is 1 ohm and this is 1 ohm. So 1 into 1 is equal to, here the opposite impedances are 1 into 1. So 1 into 1 is 1 equal to 1. So the bridge is balanced. When the bridge is balanced, the current flowing through this 2 ohm is 0. Okay, no current is flowing through this 2 ohm resistor. So 0 amps. Okay, it looks like a Wheatstone bridge. So if bridge is balanced, the current flowing through this 2 ohm is 0. Now one source is completed. Now I am considering 1 ampere source. If you consider this 1 ampere source, that is if 1 ampere source acting alone, the 1 volt source is replaced with short circuit and 2 volt source is replaced with short circuit. Then circuit becomes like this. Okay, if you observe this circuit, here also same. Here the bridge is balanced, so the current due to 1 ampere source, let it be I2. So I2 is 0. You may get doubt here. Here there is a 1 ohm resistor. If you observe this, if you find the equivalent of this total resistance, okay, if you find the equivalent of this total resistance, this resistance and this resistance are connected in parallel. Okay, if these two resistors are connected in parallel, suppose the source is connected here. Okay, connection is same. So one current is flowing like this and another current is flowing like this. So current must, how much current is entering to this network, that much of current must be leaving from here. Now this is Wheatstone bridge. It acts like source, so the bridge is balanced. So current is 0 amps. Okay. Now two sources are completed. Another source is 2 volt source. If 2 volt source acting alone, the 1 ampere source must be open circuit and 1 volt source must be short circuit. Then circuit becomes like this. Okay. Here the current is due to 2 volt source is I3. Don't change the direction of current. We can draw the circuit like this. Mention the node points A, B, C, D. Okay. In between A and D. So A and D, there is a 1 ohm resistor. Now B, D, 1 ohm resistor. So this is B, this is D, 1 ohm resistor. D to C. Okay. This is D, this is C. There is a 1 ohm resistor. Next B to C. This is B, this is C. Okay. So this negative is connected at B. This negative is connected at B. Here also negative is connected at B. And positive is connected at C. So positive is connected at C. Direction is leaving the positive terminal of voltage source. So here leaving the positive terminal of voltage source. So the circuit becomes like this. Again this is Wheatstone bridge. Now check whether the bridge is balanced or not. Multiply opposite resistance. So this is 1, this is 1. 1 into 1 is equal to 1 into 1. So condition is satisfied. So 1 into 1 is 1 into 1 equal to condition. So no current is flowing through this 1 ohm resistor. If current is not flowing through any resistor, that is open circuit. So this is open circuit. If it is open circuit, that means there is no resistor here. What happened? This 1 ohm and this 1 ohm are connected in series, and this 1 ohm and this 1 ohm are connected in series. So if two resistors are connected in series, so what is the equivalent? Summation of two resistances. So the circuit becomes like this. Okay, now again if you observe here, this 2 ohm are connected in parallel. If two equal resistors are connected in parallel, the equivalent is resistance by 2. So R by 2. R by 2 is equal to 2 by 2, 1 ohm. So this is 1 ohm. Okay, I am writing here. So entire this circuit is replaced by 1 ohm here, because the equivalent of these two resistors is 1 ohm. Now, so forget about this one. What is the remaining circuit? This 2 ohm and this 1 ohm are connected in series. If two resistors are connected in series, what is R equivalent? R equivalent is equal to summation of two resistors, that is 1 plus 2 is equal to 3 ohms. Now what is I3? By Ohm's law, I3 is equal to V by R. So V by R equivalent 2 by 3 amperes. Okay, now by superposition theorem, so what is I now? I1 plus I2 plus I3. I1, I2 are 0. So what is I? 2 by 3 amperes. Next question is, determine the diode current ID by using superposition principle. Okay, this is the given circuit. If you notice here, this is diode. Diode is a non-linear element. Diode is a non-linear element. So superposition theorem is not applicable. Very, very important point. Superposition theorem is not applicable for non-linear. If circuit contains non-linear element, superposition theorem is not applicable. By network solving techniques, here if you observe here, 6 ohm in parallel with 1 ohm resistor. So if you apply source transformation, so what is the voltage? V equal to IR 6 into 1, that equal to 6 volts. Similarly for this one, so here 1 ohm, this is 2 amps, so let it be V1, V2. IR is equal to 2 into 1, 2 volts. So circuit becomes like this. Okay, now let diode is forward bias. If diode is forward bias, for ideal diode it is short circuit. If it is short circuit, the circuit becomes, this is just our assumption only. Okay, we assume the diode is forward bias because we don't know the exact anode voltage and we don't know the exact cathode voltage. So we assume diode is forward bias. If this current becomes positive, then diode is forward bias. If current is 0 or negative, diode is reverse bias. Now find the ID by Ohm's law. So by Ohm's law, what we are getting? 6 minus 2 by 1 plus 1. So you will get 4 by 2. This is 2 amps. So ID is positive. Here ID we got positive. So our assumption is correct. That is diode is forward bias. So the diode current is 2 amps. In the next video we will discuss some more problems. Thank you for watching.